Hello everyone, welcome to Earth and Space Science reference table review. Today we're going to talk about page 11, Model of Earth's Interior Structure. So model of Earth's interior structure shown as different layers of our planet, our internal composition. We're going to start with the most outer layer and we're going to travel down to the core. We have to remember that when our Earth was forming, it was separated based on density into these different layers. Okay, first layer we're going to look at is crust. Crust is broken down to two types. We have oceanic crust. This crust is located under our oceans and it's basaltic crust. It is 5 to 15 kilometers thick, and the density for this crust is 3 grams per centimeter cube. Second type of crust we have is continental crust, located under continents, made mostly of rock called granite. It's 30 to 50 kilometers thick in thickness, and the density is a little bit lower for our continental crust. It's between 2.7 and 2.9 grams per centimeter cube. Next layer, as we go deeper into our planet, is going to be mantle. Okay, mantle density of mantle is a little bit lower. I'm sorry, a little bit higher, between 3.4 and 5.6 grams per centimeter cube. This mantle is going as deep as 2,900 kilometers, and it's broken down into upper mantle and a lower mantle. So upper mantle, we have two layers here. The one is 400 kilometers, and the other border starts at 670 kilometers. Upper mantle is more rigid, and it is including a stenosphere, and it is also attributed to tectonic plate movements. And then lower mantle is a little bit hotter. Temperatures are higher in the lower mantle, and it is believed that the lower portion of it is contributing into Earth's magnetic field. Okay, so we have our density for our mantle here. Okay, here's our lower mantle, and here is the depth, how deep into the Earth our mantle goes, about 2,900 kilometers. Next layer we have is a fluid core. Okay, fluid core density is getting denser. It's between 9.9 and 12.2 grams per centimeter cube, and it is liquid state. Okay, and that's how far it is extending in, 5,150 kilometers. And then finally, we have our solid inner core, and it is in solid state. 6,378 kilometers, and it's the densest part of our Earth, which is 12.8 to 13.1 grams per centimeter cube. So how do we know about the structure of what's inside of our planet? What we use is our earthquakes. Earthquakes are acting as an X-ray, would work for our broken bones, and that X-ray helps us look inside of our planet and see these layers. We have some shadow zones where the waves generated from the earthquake, the energy, is not able to pass through our planet. We have P wave and S wave. We have P waves that will not travel through liquid, as opposed to S waves that will bend as they travel through the liquid. And by collecting this data, we know what's inside of our planet, just like we know if the bone is broken if we use an X-ray. Finally, how can we figure out how big the layer is? We can just do a simple math, subtracting these two boundaries. For example, if I want to know how deep, how thick is this particular layer, which is our fluid outer core, I can just subtract these numbers. 5,150 kilometers minus 2,900 kilometers, I'll get 2,250 kilometers. Right, that is it for page 11. Good luck and have a nice studying.